The slope field is given by the equation dy dx is equal to kxy, where k is a constant. The value of the slope field at the point 1, 2 is -4. Determine the value of k. So we could just substitute into this. Dy dx is -4 equals k, and that will be 1 times 2 in here. So -4 is equal to 2k, gives us k is equal to -2. And so our differential equation is dy dx is equal to -2xy. Determine the equation for the solution curve that contains the point 1, 2, and draw this curve on the diagram above. And note there's only 3 marks for all of this, so they're expecting us to use the CAS. So I might actually just write down one step of working, which is separate the variables and do this. And of course, there's an x in there, like that. But I'm going to solve it using the CAS. So we go to main, and we are going to want desolve. So this one here. And there is a condition. We know that it goes through 1, 2. So the equation would be dy dx, which will write as y dash, and that little dash there is in Math 3 on your calculator. And that is going to be equal to -2xy. The independent variable being x, the dependent variable being y, and the conditions are when x equals 1, y is equal to 2. Well, okay, that maybe it would have been better if I'd had it in standard. Let's go back and redo it. And we can see that we get y equals 2 e to the -x squared plus 1. And then we want to try and draw that above. We have a couple of things that help us do this. First of all, the fact that the only sort of functiony bit of this, or the x bit of this, is x squared plus 1, and both of those are even functions, tells us it's going to be symmetrical about the y-axis. The tangent field told us that as well. We can find the y-intercept because that will be just y equals 2 times e. And e is, you can obviously use the calculator for this, but e is about 2.7. So we're looking at 2 times e being about 5.4. And we did have the point 1, 2 as well on the diagram. And of course, the symmetry tells us that it will also go through this point here. And it's going to go through about 5.4, so it will be about there. And then it's just a case of following the tangent field. So it's going to look something like this.